Good evening, everyone, and welcome to Udk Tuesday number 239, the first one this winter semester 2021-2022. We are extremely happy to welcome Mitchell and Melanie from Terreform One. Please feel free to ask your questions in the live chat or in the Telegram channel that we have. So enjoy. Thank you.
Hello, I joined the round of hellos. My name is Markus Bader, for those who haven't met me. I'm part of the Udk teaching staff. And I'm also very happy to welcome Mitch, Joachim, Mitch Joachim and Melanie Fessel from Terreform One, and I also read Terraform X. Maybe that's a question for later. What about these numbers in the Terraform? Mitch is one of the co-founders of Terraform One, and it's described as a non-profit architecture and urban design research group in New York City. He's also involved in education, learning, academia as an associate professor of practice at NYU's Gallatin School of And he's working with his practice and their practice, a couple of quite outstanding awards in the context of architecture and sustainability. Previous to Terraform, he's been working with interesting offices like Frank Gehry and I.M. Pei. And he's today here together with Melanie Fessel, who is a principal in Terraform. And she's also architect and urban designer. And she is currently lecturer and academic coordinator and doctoral researcher at ETH in Zurich. And while Mitch is joining from New York, Melanie is joining from Konstanz, if I remember that right. So we're having a truly, while I am sitting in Berlin and some others in the other windows as well, we're having a truly interneted experience here. Terraform One, I thought is super interesting to invite today because it's as I already said, it's called a research practice, and I think it's a very interesting angle on what architecture can do, or what we can do with architectural thinking to contribute to the, let's say, main conversations we have today in society. And one of those is, without question, is the conversation about how do we as a society react to the challenges posed by the climate change that we know now. Terraform, I think, has always found and is still finding a quite unique position in this context. So we will see a practice that is not focusing on building architecture and walking us through floor plans, probably, but rather finding ways of having a really, let's say, experimental and free look at sort of the vocabulary that architecture can use and bring it into the conversation about this question of climate change. So enough said. I'm very much looking forward to your presentation, and I'm passing the word on to the two of you.
Thank you, Marcus. Thank you, Helena. It is super great to be here virtually. And we certainly would have loved to have been in Berlin, and we will be there again, and especially to show our work and to also meet faculty and students in person, because the world will eventually come back to normal, and that is incredibly important. Similar to Ramlabor and a few other practices, Terraform One is a collaborative. So we work in teams, and there are many teams, and we're fairly international. And I think that is just about our generation, speaks to our generation wanting to differentiate ourselves from the more traditional or corporate-based architectural practices. We are certainly speculative, we are research heavy, and we have a very distinct mission. So I'm going to open up the slides that Melanie and I will share and talk about some of the work for about 40 minutes or so. I'm going to time it, because time is important, and get into what we've been up to for the last 14 or 15 years. So let me share the screen, and there we go. And that looks okay. Oops, let's see if this is here. Does that look good? Yeah, okay, great. So Terraform One and Terraform X, we have a European version of Terraform, which Melanie is the lead on and director. That is for various legal issues, running nonprofits, and also doing work there in Europe. I'm also a resident of Germany. Some of the publications that we've been doing, these are some of the major books on ACTAR and Prestel, and also TED. So I would suggest you, for those who are listening, check out the work that we've been doing in publishing. So a lot of the questions can be answered by looking at these texts. The more recent one is on ACTAR, called Design with Life, and it is a survey of the last 14 years of Terraform and a lot of our projects. It's got interviews and essays and really describes how we come together, which is similar to this diagram. We are a team with a multidisciplinary background. So we work from all different perspectives as much as possible at different stages of how we engage any project. So we'll team up with anyone from a fireman to a musician to an economist or a sociologist. And all of us come together to argue or polemicize about the near future of our cities. So it's not just elite architects and planners, it's a healthy group of us having a very deep, if not profound, conversation. And that's important, that dialogue. The main argument that we've had for now the last few years is this, which is extinction. This is the white rhino. It's known as an endling. They are virtually extinct from the wild. There are no more left. And this is an example of megafauna that has disappeared off the planet Earth. So every 9 minutes on this planet, another species goes extinct. Terraform's main perspective of operation and mission is to look at climate dynamics, and to think about how to stop this insane amount of death that happens almost, happens every single day, and every hour. The rough statistic, and this has been proven by the Guardian and Nature and a number of other major journals, is that wildlife population has diminished by at least half since the 1970s. That's every coral, fish, bird, mammal, insect on this planet. 50% of them are gone permanently. That is a fact, and that is a very difficult, if not wicked, problem to overcome. And this is something that architects, and that's every architect, needs to think about when they're speccing their buildings or designing. This is what architects do between Asia, Europe, and the United States. These are typical firms using these paint-by-the-number solutions to do good or to do green. So there's things like LEED, Energy Star, Active House, WELL certification. All of these certifications add up on a project to do something good for the environment. But if you drill down and look at the details of what good means, less than 5% of the points you can get for doing good goes towards biodiversity, goes towards saving the life of anything else. We are so concerned about human needs, bottom lines, and the base economics in the built environment. Even our systems like LEED and Energy Star are still privileging the anthropocentric. We're still privileging the needs of man. So our work here, our motto is design against extinction. We're not activists, we're designers and architects. We think about urban environments, and we think about action through architecture itself, not activists that are shaking signs on the streets and blocking traffic. Those people have their own reasons for the work that they're doing, and I highly respect that. I think what we're doing is trying to articulate it in the forms of diagrams and projects. So one of the major issues that we're facing is urban population increasing, which is a good thing, but human population getting up to something like 11 billion people by the end of the century, depending on the pandemic, How are these folks going to live? Where are they going to work? How do they move around? This is where architects have a major role to play, as well as urban designers. We can make a difference. Even in areas such as food, meat production is expected to double. Terraform looks at waste, food, water, energy, air quality, mobility, etc., even equality or equity in our city so that we can produce designs that are not utopia. We're not interested in utopia. We're interested in engaging the public and communities and our fellow architects and urban designers so that we get to some level of consensus to work towards civilization 2.0. Here, we're seeing things like more vehicles on streets than ever before. Architects and urban designers have a say, not only in the patterns that these vehicles take, but also the technologies that allow these vehicles to be optimized and more efficient, and also the design of the vehicles themselves. We can actually do that. We don't have to accept that these are the things that move us around. This entire field, we call it socio-ecological design, which recognizes that society, the capricious public, the leadership class, and the government play a major role in how we think about architecture and urban design. So it's, again, it is not just a small group of people speaking in a bubble, but we need to recognize that there's many larger concerns and as much as possible work on them. One project that we've done recently for the TED Countdown was to produce these anti-extinction archives. So these are eggs that contain an endangered species, fertilized eggs, and that decay over 7 to 9 years and then release all of this material into the environment. So on the inside, there's cryogenically frozen petri dishes with embryos. In this case, it's a rare salamander that's red listed and endangered. Then seed bombs for the various flora and fauna that it needs to survive in the future. So creates an ecological patch that over time, as it gets released, provides not only the actual organism itself, but the things that it needs in the environment to thrive. So here you can see in these diagrams, the egg slowly decaying. The surface is made out of phase-changing materials from different types of mycelium to plyboo, and then eventually it releases the seed bombs and some of the patch ecology, and then an individual would come and open up the central cryogenic chambers and release the creature into that environment. It's also placed out there for the public to realize that every 9 minutes, another species goes extinct. So these are very large objects. They're very obvious. They're monolithic. They're slightly intimidating, but they come with a raft of information about the consequences that individuals have in the environment and how to make change, such as electing the right officials to power to stop this madness. It's one of many routes to do that. We have a facility in the Brooklyn Navy Yard. Brooklyn, similar to Berlin, is thriving with the creative class. In fact, the largest amount of creative class people are in New York City and Brooklyn. We welcome any one of you folks to come and visit us there. We have our laboratory in this facility that we built with the government. It was around a $46 million grant to get this facility and turn it into what we call a new lab, where we work not only with architects, but with a whole host of different companies working in anything from robotics to new types of batteries to different types of e-bicycles. So we're architects embedded in a swarm of other thinkers. And we're not just working on our laptops, we're making and building, productizing, and micro-manufacturing our ideas. And I think that's key. So it's not just working on a laptop, we're working side by side other companies and turning these things into reality, moving them into fruition. So we've got a whole host of shared shop spaces and machines, material libraries, printers, areas for sewing, built or textile design, clay use, to electronic workbenches where we actually build our own circuitry in this laboratory. So it's 88,000 square feet. Terreform One is the founding company, along with a few others. It took us years to put this online. We work in a kind of a garage-like setting. So architects traditionally are in the atelier You'll see many rows of people on laptops. We're not like that. We're in a laboratory. It's a mess of materials and organisms where we're designing projects that have no precedent in many cases, and that take 7 to 10 years to get off the ground. So it doesn't happen instantly. So you have to defer your gratification. We also started our own fully functional wet laboratory, here working with our Chief Science Officer, Oliver Medvedik. He runs the Kembar Center at Cooper Union for biotech. And here he's teaching architects and designers how to do genetic work and CRISPR, how to work as biologists in a lab so that our materials and our studios are combined. So it's a combined studio/science lab. And you need people side by side to get this kind of work done. We also teach our folks how to build their own machines. So do it yourself, or DIY, is a big part of how we function. We don't want to just use big, expensive toys. That doesn't impress me or anyone. We actually want to make things that can make other things. So here is a thermoformer or a vacuum former that we can actually make on your own in a kitchen, and then make models and materials with the thermoformer that you built yourself. We also do a lot of urban farming. So we don't just talk about green, we've got green thumbs. So here on a rooftop in the Metropolitan Exchange, we had a thriving urban farm for years. Here we're grafting tree species together to make one contiguous poplar tree. We're also looking at lightweight pectin impregnated or clay impregnated soils that go on roofs and do roof gardening. We're looking at gray water cleaning through phytoremediation, or using plants to clean the filth that comes out of our sinks and our showers. And it's important as architects and designers that you build these things and grow these things so that you know specifically how to spec them when you go to a project and turn it into reality. So here's some other projects that take our spaces and move them into reality in these categories, which is ideas of mobility in cities, the food that we're eating, and how we live. This is a concept I had at my days at MIT and continues from MIT. These are soft cars that move in flocks and herds. The entire drivetrain is in the wheels, so suspension, motoring, and a modicum of intelligence is in these wheels, and the rest is an architected envelope that is made out of air bladders and ETFB foil quilts, so the car is super soft and it doesn't move fast. So it's smaller than a smart car, moves very slow, and is designed to bump into other cars. It's called the Hug and Kiss Lamb car. It's made for dense urban conditions, and it's a shared ownership model similar to Lyft and Uber. We also produced this car, which took around 15 to 18 years from a napkin sketch to something that you can purchase. It's called the Heroku. It's a car that stands up and is designed to park. We looked at the perspective of cities that most cars, 23 hours out of the day, they don't move. So it's a storage problem, it's a parking problem. So these are vehicles that are shared, but they're also designed to stand up, spin around omnidirectionally, and have a new agility on how they explore cities. And all of these things become more than just functional routines, but visionary drawings that are points to argue, because no one has a perfect vision, and we don't even pretend to do that. So here we're looking at trackless trains, we're looking at transforming streets to be riparian corridors that basically privilege aqueous life. Yes, there'll be some insects there, but that's okay, they can be moderated. And we look at vertical gardens and farms for air quality and food production, solar cells and wind turbines, all combining into this idea of the future of 42nd Street. Now, it doesn't have to be exactly this, but we want the public to engage images and ideas like this so that we can move the needle, get us out of the system that we're in. And when we come to thinking about cities, we also experiment with analogs of computation. And here Melanie's going to talk about how we used E. coli to make a map that is the entire map of the world in all of its largest cities, using a form of lab-based transgenic E. coli to map populations one-to-one to the world's densest cities.
Exactly. Thank you, Mitch. I'm taking over here briefly, explaining this project. This project is the Biocity World Map, and it's a cartographic installation based on the Dymaxia map. Buckminster Fuller developed this some time ago, and it looks at population growth within the next century. And it views population density in cities based on probable census data, making aware of the consequences also of uncontrolled growth. Next slide, Mitch. So our Biocity map displays population density as a parametric graph on the front, and on the back side, it is made with living biosynthetic transgenic matter. And we chose the colonies of E. coli as a method of demonstrating exponential population growth using synthetic biology. So the population density is represented in two different forms of transfluorescent transgenic light under UV light. On the one hand side, we have the glowing red E. coli, which represents future census projections. And on the other side, we have the green E. coli that represents existing demographic conditions that you find in cities today. Next slide, Mitch. So these living elements focus on 25 megacities, and those are genetically designed and grown inside a petri dish. So here you see one of my colleagues that experimented with living populations that consisted of billions of bacterial cells. And ultimately, the aim is that those bacterial shapes grow to reveal varying patterns of transformation in urban regions. So this is important. We're actually looking at whole urban regions, not isolating the city boundary anymore. And here you can see the microstencils that are derived from CAD files and then shaped by the E. coli into the specific geometries that display the current geopolitical boundaries in cities. And next slide, please, Mitch. So the map here again, we start to see how it comes together. This was obviously built for an exhibition. This was actually part of the Venice Biennale in 2016. And the map visualizes the Earth as one entire urbanized place. And so this is instead of connected settlements, municipalities, and regions. If we are anticipating this growth at the current rate, almost everything in human society will be comprehensively stressed. So this system pressure also includes, just to name a few, Mitch actually mentioned a few before, but that's water scarcity, food shortages, overcrowding, air quality is an important point, but also traffic congestion. And I think we must recognize these universal challenges that we have in this century, especially here lecturing today at the Universität der Künste in Berlin. I encourage everybody to get on board with this topic. Next image, Mitch. So the Biocity map, just to finish up this project, is an example how we work, right? We're working in interdisciplinary teams that involve people like cartographers, but also urban planners, biologists, and also architects to complete and manifest this future population density by using biosynthetic materials. And yes, now actually, Mitch, I think we're now moving to the next project, which even goes further into the field of using biosynthetic materials to actually create some of our designs. I think this is an important point. We are designers and architects, we are creating. And the question here is, why grow a surface? And the answer from my perspective is because we can. So here, these prototypes are made of a microform surface system that are the intersection of parametric design and synthetic biology. Next slide. So here we have the evolution of chairs from, the 19th century arts and crafts movement to the 20th century industrial innovation and mass production. And now we're proposing in the 21st century a multi-curved mycelium mushroom structure that is grown from organic materials. So we're not extracting it from the earth, but it becomes part of the synthesis with the earth. Next slide. So the multi-curved shapes, and here you see just one example. In the beginning, we actually had to start at a very small scale, due to the constraints of our DIY tools that we built. But the multi-curved shapes here are actually cut digitally, and then they're they're grown in segments. So the idea was this additive manufacturing. And the fungi is then shaped into specific geometries within the piece. Next slide. So the microform, of course, our design evolved and it also changed in scale. And eventually we were hoping it to become architecture. But it's a product that's grown from ordinary biological matter and added to precise compacted forms of inert waste with the enzymes that actually digest a variety of cellulose based on agricultural byproducts. So here we can see the kind of infill that takes place. And the internal filler is made up of mycelia substrate that is a combination of discarded wood chips, gypsum, oat bran, because you have to feed some food for the fungi. They're very hungry. And then it is actually consumed by mycelia and hardened into a tough, durable, and functional material. Next slide. So then what is important about this project is that it then integrates to become a hard biopolymer that is suitable for architectural applications. So here we can see it was meant to interlock and actually create much larger shapes than just a chair. Next slide. To finalize this project, at the end of this product's life cycle, the intention is to compost it and safely reintroduce it back into the environment where it can naturally biodegrade. And now, yes, next project, Mitch, with you.
Okay. Yes. I mean, simply put, those are chairs you can eat. And that was our goal and our mission, producing materials and systems that are holistically connected, as Melanie said, into the Earth's metabolism. We also do things like this, highlight the problems. So this is 36,000 tons of trash or waste in a city every given day, roughly larger than the the Statue of Liberty in 1 hour. So the public gets an idea of why we need to move out of the former industrial materials into materials that are fit into the earth. Here we show another project that deals with waste. So if it's not a chair, it's something like styrofoam. Styrofoam is a major problem in cities. It's very hard to recycle or upcycle. We've discovered through some work at Stanford that these mealworms, common everyday mealworms and Amazonian mealworms, digest styrofoam naturally. So they get rid of this unbelievably wasteful product that is universal all over the world. And we found a system where we can use these very simple little creatures, these insects, that digest it and then produce compostable mulch that then goes into our gardens and grows other life forms. And here it helps jumpstart biodiversity. So we produced a project for Camden, New Jersey, where we made these digesters and a system of showing how these digesters might operate so that the public can stop dumping in Camden, which is a very difficult community that suffers from joblessness and a whole host of other urban blighted conditions, especially junk space. And we thought of a way of creating these, a public sculpture that explains that they don't have to just, let waste go into discarded empty areas, but that there's a way of processing it naturally. So here, this project is a decomposition clock. It is a digester, and it's a pollinator garden, as well as a farm for growing tens of thousands of mealworms that eat the styrofoam in the belly of the beast. So the farm system is an architecture for these insects, and that they're grown. On the top is a clock that explains over time how long it takes for different materials to return to the earth in organic ways. And then in the base of it, here through the oculus, through the center, is an area where we have the digester actively working with mealworms to eat styrofoam and turn it into mulch. These mealworms then turn into darkling beetles, and they leave the shelter system or the digester, and they're eaten by all other kinds of creatures in the area, thus jump-starting biodiversity, increasing biodiversity in a space that has almost nothing because it's been devastated by various urban activities that have left it alone and fallow. So here you can see in the back, all of these units are for growing the mealworms as insects that then are moved to the front of the system where they digest styrofoam that is donated by the public and the municipality. So they throw in as much styrofoam waste as you want. The worms are going to digest it. Here in the back of the system, we've planted all of these local grasses and pollinators that help bring birds and other life forms to the area that are attracted by the darkling beetles that then help turn this, what we call, I guess, junkscape into something that is viable and thriving. Here is the center, the belly of the beast, where the mealworms are eating the styrofoam. They do it very slowly, but it works without any chemicals, without any carbon, more or less just the worms silently crunching away, eating waste. And another project that looks at maximizing green when it comes to materials. Here is an ongoing research endeavor called Engineered Living Materials. There's a number of projects that fall underneath this idea, but it's growing living materials into specified geometries that are either used for structure or facade systems. So it started a long time ago with this project called the Fab Trehab, where we decided to grow an architecture in situ where there's no distinction between landscape and building, that the in-between forms, which are attached to old growth existing trees, are made from vines that are shaped from computer scaffolds that then grow into place and form dwelling units for human programmatic use. We've now gotten more advanced and produced these bioreactors that grow specific plants just as a taproot. So we're teasing nature to grow elongated roots in dark and moist chambers that are ultrasonically driven. So we get essentially pliable 2x4s that we can then shape over scaffolds and make into building environments. This is our latest version of it called Home Alive. We were just in a show, the Planet Love show at the MAC in Vienna, where these models are now part of the permanent collection. But here we're looking at a variant of growing different types of ficus and clusters of willows into eventually specified geometries. Here we're producing a scaffold. The scaffolding is made out of plyboo, and then we have clusters of willows that form what we call digrid trusses and structures that eventually make usable envelopes. This is an architecture that is the least embodied energy material you can find. It is a positive contribution to the environment because these materials remain alive. We're not killing willows, we're actually growing them into shapes. A great thing that we've learned is that in a few places, especially Germany, we have massive agricultural endeavors where we grow things like willows to 2 or 3 meters in length, and then they're used to create energy. They're pelletized, and productized, and then eventually burned as biomass to make various types of fuel systems. This is certainly better than coal, certainly better than oil. It's a much greener material. It's not the best, but we're actually thinking of changing that relationship from agriculture and energy to also agriculture, energy, and architecture, using those willows that are pre-grown on farms and then shaping them into geometries that eventually become housing components. Here we're using algae sacks for windows and a number of other plyboo products for some of the central structural cores, and then attaching them to old growth trees, and then connecting them to digrids of these complex willows. Also changing the scale. It actually can not only be a single story house, but it can go vertical. So here's the Arboreal Tower, which is a project that we're doing for the largest urban park in the world. It is the centerpiece, creating a vertical landscape, not only of a farm on the inside, which is protected, but also on the exterior using engineered living materials to shape the digrid made out of mass timber to serve as the infill for architectural space. So in this case, they're not the structure, but they are the facade systems themselves. And they fit into the base of the building alongside the CLT or mass timber construction. And they're also using plants that are part of the local biota. We look at all kinds of drought conditions and different species of plants that will grow vertically in this particular arid climate. Also educational centers on the interior that talk about farming, where food comes from, the meaning of plants and insects, and how important that is to us as a society. So it's not just a building that is a folly, but it's actually an educational center. We show here specifically how we're guiding the rhizomatic root structures and grafting the canopy of one plant to the base root of the plant below it. And then we protect them from weather conditions by putting them inside these different types of sheathing mechanisms that protect the roots, so the roots can grow into roots, can grow into roots, and can grow into roots, and then follow a geometry that we've predetermined. Eventually, this entire facade becomes one living, thriving root to plant structure. It's also protected from the amount of water usage, which is extremely minimal because of the environment. Is the evapotranspiration is not allowed to happen. It's kept inside the pots, and we use a lot of sophisticated hydroponics. So then on to the last two projects here, looking at food itself. This was our client at Terraform for some time. This client was a cricket. The idea was to eat this guy and thousands of others. Meat production is a problem in cities. Cows, pig, chicken, we're eating all of that stuff all the time. Why use crickets? Because they're 2,000 gallons less water for the same gram of protein you get from a cow. There are also 300 times less greenhouse gas emissions for eating cricket or bug powder protein versus cows. We've done these analyses comparing urban conditions versus rural conditions, the same amount of acres producing the same amount of protein, but the cricket powder itself is unbelievably efficient and saves in carbon, greenhouse gas emissions such as methane, and also water usage. So these little pink areas produce the same amount of protein you need inside a city versus a landscape which uses about 98% of those acres for cattle production. So here we've been working at different types of architectures for our client, the cricket. We make sure that the architecture for this cricket is as happy as possible and produce this shelter for the cricket itself. That's also a farm where every 6 weeks the crickets die naturally, and we harvest them, ground them into a powder or mill them into a powder, and produce things like bagels, bonbons, pasta made from this cricket powder. These crickets are actually not outside of the shelter. They're model crickets to give scale and to show you that the different mechanisms here that we have a patent on are for the distribution of crickets over their life cycle. So they get fatter as they eat lots of food. We tune their metabolism by feeding them lime rinds and orange peels and apple cores. So we actually change their flavor, making the powder system more desirable for humans to eat. And we know it's going to take some time for humans to eat bug powder, but the United Nations since 2013 has said that Europe and the United States needs to get off of eating cows, pigs, chicken, and lamb. We need other sources. The systems on the top are wind cowls. It actually picks up these vibrating columns of air as we cool the colony passively, and you can hear the sound of the crickets chirping as the entire colony sings when the males are very happy and they're searching for females to reproduce. So that's what these spikes are on the top. These are also cricket pods. These are essentially hotels for the crickets to meet and to propagate their genetic material inside these private little hotel rooms where they redistribute their matter across the entire shelter. It was a lot of fun architecting those interesting cricket hotels. And then another project here is the known as the Urban Farm Pod, or the Plug-in Ecology. And Melanie, I think you wanted to say a few things about this.
Yes, I can just say a few things. So the Urban Farm Pod here, what we're seeing, it's a living cabin that was grown, but it also provides daily vegetable needs, and it is an interface with the city. And what we see here is that the sphere prototype is a robotically milled rotagrity ball for the undergrid structure made of reclaimed flat pack material. So this is really about how it was built, but it also has a fully operable sub-irrigation system and is shaped from foam panels. And it can be outfitted with a number of optional systems to adapt to different locations. Here we see it in the heart of New York, and the pod archetypes basically adapts and turns the food system itself into a visible artifact, but also a bioinformatic message system. And the next image on this, just to kind of summarize, but it sets out for the direction for a healthy biological exchange with our urban inhabitants, but also to contribute to the life of urban ecosystems that mediate between autonomy and community. And Mitch, you take over this part.
Oh, we developed these zero petrochemical panels that hold double skin pots with wicking irrigation systems. There are 9 columns of irrigation that trickle feed the different plants, and you essentially grow your food. You grow your food, know where it comes from. You want high yield crops, not wheat or corn, which is not practical to do in cities, but you want stuff like arugula, mint, spirulina, different herbs and spices. So you grow those components in a balcony, a rooftop, or inside your apartment, and have a relationship between the food that you're eating and where it comes from. So we go from pasture to plate with this farm/cabin product. It's both furniture and farm all in one. It also rotates to get the most amount of solar income and has different types of grow lights on the sphere to get all different types of lighting systems onto those plants so that they grow at a regular and controlled basis. And then finally, the last project here is looking at the extinction of this beautiful species of butterfly called the monarch in New York City. And this was coming from a developer that wanted to do something more than just do an eco building. Here he wanted to do something that was super ecological and care for a species beyond just human needs. So we have a facade system that looks at the life cycle of butterflies, the monarch specifically, their relationship to milkweeds, where they lay their eggs, their chrysalis stage, their caterpillar phases, and integrates them into a semi-porous open facade that allows these creatures to move in and out and rewild and increase the biodiversity of the urban region around it. We also have a patent to do this on almost any other type of small to mid-sized species that fit facade systems into biodiversity. We build these terrariums that are structural and modular on the outside of buildings, and they're integrated to the holistic picture of the building itself to save many species from red listing. Here we have a pollinator garden and education center on the roof. Also through the atriums of the building, there are areas for the butterflies to occupy that building. So it's not just occupy Wall Street, but it's occupy everywhere, and not humans occupying it, but insects. We communicate the drama of those insects with some LED screens so people from far away can understand that this building is a sanctuary for the monarch butterfly. We got a grant from Intel to do that. They were very interested in producing these low energy OLED screens on the surface. And the entire building on the exterior is fitted with this sanctuary that allows the butterflies to drink, to sleep, to eat, to reproduce, and thrive inside the city. Also, we're commissioned for the American Museum of Natural History to do their insectarium. We just produced these. We looked at specifically how to feed butterflies and how they lay eggs, how they find areas of respite, and what they do when they sleep. So these are actually installed butterfly feeders, different geometries for butterfly feeders that are integrated into workable facade systems. Those geometries then printed with large-scale rep wraps or large-scale 3D printers, produced with bamboo-based scaffolding and zero VOC silicon molds that are medical-grade molds that actually are not dangerous for people using them. And we make tens of thousands of these casts. We worked with BASF, which is a very large corporation here, producing the greenest concrete that's both structural and fireproof and spec'd for buildings, designed with the geometry of the needs of monarch butterflies. This concrete also contains fly ash, so it impregnates carbon-based material that is waste material from different types of burning energy plants. It's impregnated inside the concrete so that we're holding on to that and sequestering that carbon over time. And then coming up with a concept for that concrete to fit into the skin of the building in this double skin facade, where we have mud baths. Butterflies love mud baths, different types of artificial flowers and feeder systems to continuously feed the butterflies and give them a chance at surviving. We've lost 90 million of these monarchs over the last few years. According to the United States Fish and Wildlife Service, we will no longer have the monarch butterfly if this continues. Here we are, we produced a full-scale, fully operational facade system that we did for the Smithsonian Cooper Hewitt Museum, where all the functions of these concrete systems and their different plants, both real and artificial, for feeding and for reproductive purposes, were built into the facade system for the butterflies. All of these are bioplastics and easily to readily made to upcycle and keep these butterflies thriving. Here, these are actual monarchs in the space in the Cooper Hewitt. This project has gone actually all over the world on display to show that architects can make double skin facades, not just for human needs, but for needs of some other organism, to truly design against extinction. So these aren't robots, these are actual monarchs hanging out, sleeping, resting, and wafting through the space. So that is 40 minutes exactly, and that is just some of the work that we have been up to at Terraform. And we're really happy to, did I stop sharing? I don't know. Really happy to take some questions and to have a dialogue with you guys at this moment. So I think I stopped sharing, but I can't see myself. Am I done?
Well, thank you so much. You stopped sharing. You've also stopped sharing your own video.
Oh,
So, I believe at least.
okay.
So thank you. There you are again.
Okay.
Thank you, Mitch. Thank you, Melanie. This has been incredibly insightful, amazing. We have invited 3 of our students to begin the round of questions and the discussion panel. Let me just remind every viewer that you can always post any type of questions that you might have in the live chat, and we will read them out. You can also contact us via our Telegram channel. So I will hand over the word to our students.
So, hello, I'm Dugan. I'm from South Korea. Nice to meet you. And first question is, where to get the inspiration, and how to get inspiration when you design something, the buildings and ecological buildings?
Melanie, you want to take that first? It's a great question.
Well, yeah, thank you so much also for your great question. Mitch actually mentioned before, I personally have just was part of the curatorial team of the MAC exhibition Climate Care in Vienna. And you know, our whole discussion always revolved around that we need to integrate circular design thinking in how we as architects operate in the future. So I think they're very urgent questions that relate to climate change, biodiversity, species loss that we urgently need to address. And I think design has the power to make it visible, but also to make exciting moments that people can enjoy. So I think there's still something about beauty in design that, you know, relates to also the way we're working on this topic.
Yeah, that's a great point. You need to, I mean, we're not engineers only. If we were just engineers, it would be just some structural facts and nothing more. And at some point, when you drill down into the details of an industrially designed object, artifact, or an architecture, or a vehicle system, or a landscape, you solve the practical things. You solve for utility, and you need to do that first. It has to function well. But then there are moments when function's done, and that gives you opportunity to build in something that is what I would call build-in desire, something that's fabulous, enticing, engaging, cultural, magnificent, so that the public and anyone else can become a part of the project. And I think that's really key. It separates architects from engineers, and it doesn't necessarily have to be beauty in any traditional form. I think this century is about beauty comes through process and through making arguments about the meaning of those forms and why they're there and how they're good for the environment and what they do for climate change or what they do for another species. So they still have another layer of functionality. They're not beauty for beauty's sake, but the inspiration needs to be both in us as the designers and those viewing it. It has to be a two-way street. So all of our projects, we do something to just take it to the next level. And we fight amongst ourselves. There isn't one ego here. We have a lot of discussions on what the final look is, and it's not easy. But we get to a point where we just have to say, okay, we're done with design. Let's get it out there. And then some people will love it, some will hate it, but we always have the next project to work on. So it's key though. The things that inspire us the most are things that don't have a voice, whether it's mealworms or E. coli or mycelium or mushrooms or butterflies. Like, this is the stuff that inspires us, because previous architects just ignored that. Frank Gehry, I mean, I love the guy, but he could care less about butterflies these days. Or maybe he does, I don't know. But he's got 50 years of projects that don't necessarily recognize them, and that's okay. Our generation is very much about dealing with the crises of the environment and especially biodiversity loss. That's an inspiration.
Okay, thank you.
Do you want to answer that question?
And also, I have one more question. And I also wonder, what is your observation perspective when you do design? Like when you do just like normal days also, what I just wonder about, what's your observation perspective? What you see, yeah.
What we think. Well, you know, that's a great question. Observation is everything. I mean, we don't start a design knowing what it's going to be. So we look at behaviors, we look at the way things operate, we look at their life cycle, we bring them into the studio, or we go out to the field and we observe what makes them tick, what they like, what can we do to celebrate those moments? What is something that we could do to respect nature and enhance it and return it back to our cities? So it's really, observation is all we do from every single vantage point at multiple scales at once. So we're not operating at just the architectural scale. We operate at the scale of a region or a city. At the same time, we operate at a molecular scale or scales of materials and surfaces. Architects are responsible for all of it. We need to be accountable, and through observation, we can make decisions and processes that lead eventually to a project. Again, it's not perfect. We're not dogmatic. We don't preach this stuff, but it's been a healthy way for us to understand how to make work that we are comfortable with.
Well, also, maybe can I just add to what Mitch just said, when he says we, and I think I made that point before, we do work in interdisciplinary teams. And I think architecture and urban design has always been a discipline that is trying to engage with other topics. So also often some of our inspiration does come from scientific papers. Actually, one of the first tasks I'm giving to my students in the design studio is to analyze the scientific paper and make a research project for it that eventually will lead to an architectural and urban design. And I think the interdisciplinarity in our field will be key in the future. And it actually goes beyond just talking to engineers. We have to talk to planners, cartographers, biologists, epidemiologists. I think that's important these days. And I think this is also when it becomes exciting, when we see those intersections between different disciplines, but also how it can feed back into our designs that we're generating. Yes, just wanted to make that point.
I would love to chime in with a question that I got from the audience, which also connects. I had a somewhat similar question as well. You mentioned that your collective works in a non-profit structure. So the question came in, which institutions or companies are the most interesting as collaborators? And are there specific universities or students from universities involved in your research and work, apart from the cricket?
Yeah. We, as a nonprofit, we are a federally mandated 501c3 nonprofit. We also have a state license to do nonprofit work. So it separates us from necessarily, we don't always have to work with private developers. And I think as an architect, I honestly didn't really have that desire where someone was telling me what the brick color is and not really caring about the meaning of the building in its relationship to a context, except getting the bottom line finished and making sure the thing stands up. Not all developers are like that. There are some that are enlightened developers that want to do projects that are amazing for the city, the people, and the planet that they will eventually occupy. But we have a certain amount of private developers that we work with, and then we work with institutions, educational groups, and main corporates. So the institutions are anything from the Philadelphia Museum of Art to the Smithsonian, the Cooper Hewitt, to the Holland Museum in Tel Aviv, to different biennales, whether it's in Venice, Vienna, Shanghai, Shenzhen, Cape Town. I mean, there's endless amounts of galleries and shows and museums that we're a part of, even the Tallinn Biennale that's coming up, that really helps drive the dialogue of our work and lets us do the kind of work with the freedom that we need to then make our arguments to a certain level of sophistication. So those institutions are really important. And then big corporates, whether it's Intel or BASF or I mean, I should name them all. I feel like I'm promoting them. They are there are numerous amounts of groups, including EDF, EPA, that want to, on some level, there is ideas of greenwashing, but when they contract with us, they know up front, we do the work that we're doing and they can sponsor it, and that's about it. They can't interfere with the decision making. So we have had amazing relationships with some of these big groups. Zumtable also was great, the lighting company there. I mean, that allow us to do work and give us the opportunity to further this research. We also work really hard to then figure out how it can become a laudable business model for them, because they are in fact interested in making money. So from our enterprising endeavors for the environment, is there a way that they can actually benefit? And of course there is. There is a way of turning green into gold, but we don't start off with that mentality, and we don't come from necessarily that perspective. But all of these institutes and corporates and some private folks help us engage the work. Right now, one of our biggest patrons, ironically enough, is Kanye West, who is an interesting rap star that is a sort of Louis XIV individual who wants to save the world, but doesn't understand the general physics on how to do that, and funds groups like ours to do big think projects without limitations and with all the funding we need and resources to make them into reality. There's very few people like that, but we do respect doing that kind of work. And we're also not interested in the kind of the Starchitect model where we're, have big name clients and promoted as such. There's enough Starchitects out there, and the work that they can generate, that's already fine. We're not that group that does that.
Thank you. Maybe you guys have another question for Mitchell and Melanie.
Just one question that connects. You already mentioned Kanye West as a funding source or person. What else, or are there other resources or sources of your funding? Of course there are, but what are those?
Yeah.
Well, maybe Mitch, before you get more in the detail, thank you also for this amazing question. And I think I just want to highlight again that a lot of projects, they're unsolicited projects. And I think Markus Bader can speak to this, coming from Raumlabor, engaging in the city as a laboratory. And often, in our case, our research projects are driven by interests and research questions. just like you drive research at universities today. And Mitch already mentioned that, we're also all engaged in teaching in academic levels. We think it's a great way to explore some of these topics, but of course, funding is always of the essence, but there are also ways how you can apply for grants, for example. No, you can work with corporations, but you can also apply for grants. And now maybe Mitch, you have some more detail to this, but I think this unsolicited project way is really also a new way how many interesting architecture offices are operating today. This very non-traditional, but hopefully it will become more traditional.
Great. It is a great question and a great point, Melanie. Not only do we do unsolicited work, which is kind of fun, but wicked difficult, we also do what we call unfeasibility studies. So it's the opposite of a feasibility study. We do a study to think about how impossible it is to get something done, whether it's a small work of architecture to envisioning ideas of future streets and cities. You as a student should think about doing unfeasibility studies without limitations, only with a mission in mind and a program about your deepest interests, such as what do we need to do to stop climate change? And you're going to have to ask those questions because it's not a simple answer. The funding part of it, yes, comes from grants. I don't know if grant writing is in your future, but we do a lot of grant writing for the National Science Foundation, for the Arts Foundations, and everything in between. Terraform sort of bridges many worlds where we do get access to different grants. That's another source of funding. So we successfully get these grants every year, but it's difficult. You have to write at least 5 or 6 of them to maybe get one. And grants, unlike projects, if you lose it, you lose all of that work and effort, and it's pretty much gone. In many cases, you have to apply and apply again the next year and apply again the next year, and so on. It's very important to learn perseverance in this field. You're gonna fail or you're gonna lose, whether it's a competition or getting a grant or looking for funding. You just need to realize that that's okay. You need to get stronger, more resilient, and go for it again, because as you do, there is a learning curve. And eventually you get into a place where you figure out how to fund projects and self-fund projects. If it was easy to do, we would write a book and everyone would do it. Right now, it's not exactly easy to do. And I've had 13 years of school for 2 master degrees and a PhD, and I've only had 1 class in professional practice. I guess it's just, I'd probably, if I was to suggest to you, I would spend some time thinking about how the business school operates, if you can get access to one, and learning how to write grants and work on commissions, understand contracts, and all of the other stuff that makes a business operable, including your overhead and your costs and dealing with paying your staff and everything else involved, from insurance to travel. Look, it's not the fun stuff, but 50% of what we do is that funding and contracts and insurance, et cetera, and that's a reality. So it's good to point that out, but that's part of the work.
Speaking of the traditionalism or the type of work or the structure of your office, there's another question that came in from Victor that connects quite well, I believe. So it goes: do you publish the blueprints of your projects so that other people can copy and adapt your processes and designs, or do you keep them secret, or do they belong to your funding partners?
We publish everything, and we make it all open source, and we want people to steal from us, to borrow, to copy. Go ahead, please. The more people doing this kind of work, the better. There's not that many out there that do kind of engineered living materials or biotech and architecture. There are many more that think about sustainability and climate change, but there's just not enough. So yes, as much as possible. Obviously put credit where credit is due, but we're not profiting off these things. So if you've got an idea for a mushroom chair, go for it. And by the way, we were working with mycelium now, I think like 14 years we've been doing this. The same time, Ecovative and Phil Ross. And projects like this are now permeated through most schools of architecture. And we don't own the rights to it. We don't want to. We have patents on a lot of these things on some level because of the contractual obligations, but we also open source them. We just have those patents so that we can protect the intellectual property and make sure that it's not going into the wrong hands, because on some level that can happen. And but I guess if something good goes, well, I don't know what the wrong hands would be. That's a good question for our lawyers. But I can imagine there's some out there. Yeah, without naming names. So we're okay with that. We do a lot of vertical farming projects, and yes, all of those those plans are available in our publications, our websites. Yeah, we try and daylight everything as much as possible. I don't know, Melanie, what's your thought about that?
Yeah, well, maybe, I mean, what always comes to my mind is Elon Musk, and yes, just the same concept. He's much richer, of course, but he provides everything as open source data, and he does that so that his concept can be improved for the for humanity in general. And I think this is also our goal, right? We're not hiding some secrets, but hopefully our mushroom chair develops into something much more practical and exciting, and somehow becomes part of how we actually live on this planet. And I think that's really our idea, completely open source.
Yeah, I think Melanie has just made us the Tesla of architecture, but we're not exactly that. Tesla's a decent company. It's sort of now giving a lot to the military, and some of our work has been borrowed by the defense agency and the Pentagon. So there's a group called DARPA, which is right next door to Terraform in the Navy Yard, which is a military institution. And they were very interested in using mycelium and woody plant matter to hide electronics, radar, and missile arrays. So it almost disappears if you can grow different types of woody plant structures, mycelium systems, and other living plants in and around military equipment. So it becomes fully camouflaged from different types of LiDAR and satellites, etc. That's not our interest. So we're not big on doing defense for the United States, but that does help fund some of the projects. And that's a curious problem. And that goes back to John F. Kennedy and the Apollo missions, where the space program definitely helped the military. Actually, it came from Van Braun and Germans. So thanks for the rockets. And then it went eventually into everyday consumer goods and technologies that all of humanity has benefited from. So it's very hard to just limit yourself to one sector of operation. The military is going to have a say, science is going to have a say, humanitarians are going to have a say. You have to find agency as an architectural group. And that agency is what you stipulate up front and what you declare as your mission. And then if many others interpret it differently, you just can't control the world. And we're not trying to.
Thank you. Kolja, I think you were just about to also ask a question.
Yeah, hi. Nice to meet you. My question, I was interested in architects under in a capitalist society have to earn profits with every project. I mean, architecture is a service. So for most architects that are not part of an NGO, you have to accept unsustainable projects. Isn't it in the design of architecture that aren't architects quite incapable of inciting real change, and aren't we quite weak as a discipline in really fighting climate change? Yes.
Melanie, you could hit that one first. That is
wow, that is a big question of tonight. The construction industry is one of the biggest contributors to climate change, I would say. So taking your question, I think we have to do more. And I think it's very obvious that to young students like you are, we actually also have to look into our educational systems and really make those questions more relevant so that you can run these unsolicited projects in the future and hopefully contribute to a better society. So I would like to ask every architect to question some of the more standard methods that we're used to. And I think there are many architects out there that are trying to engage with the question of sustainable design and also sustainable communities. Mitch and I were just publishing as part of the social development goals from the United Nations in a chapter called Sustainable Cities and Communities. And I think it is crucial that we will have sustainable cities and communities in the future, and architects should play a much more important role in that. So Mitch, yeah.
Yeah, no, great question. We have been authors, a part of the United Nations SDGs, or Sustainable Development Goals, and that's almost like the outline or the general sort of metric that all architects across the globe should be using as a set of terms and rules for engagement in any project. And then you can make arguments with your clients or big corporations that if you violate these goals, that you will be recognized as such and potentially called out. It'll be bad for your business, bad for that government, or bad for the people associated with it on some level. Now that's a bit of a shaming model, but that's where we got to start, is those suggestions. And the UN is doing a great job in giving us that platform to operate on. And it's authored by other architects and urban designers and planners. So it is the best of us thinking of the most radical ideas to transform our civilization, to get us out of this temperature rise, to get us out of the problems with climate. And we can use that as a point of negotiation. Capitalism is a beast of a problem. I mean, you may know that you are in the Anthropocene, and the Anthropocene is also known as the Capitalocene, that all of these activities are driven by commerce that's generated without limits, that we extract resources on this planet nonstop. In fact, we're not even slowing down. We're accelerating the extraction of resources. So you can make arguments about what was done in Paris with COP25, what's happening now with COP26 in the future, but it actually hasn't made a dent on climate policy, and it certainly hasn't affected industry. And many of our colleagues as architects are almost seemingly powerless as they engage in clientele to continuously do projects that are committing biocide. I think that architects themselves, most of us, are great people, well, good people, I'd say, and they're aware of it, and they're kind of caught in the middle. But you certainly don't have to sell yourself out or compromise your beliefs to work for any architect or in any capitalist system. You will make that choice, and you can eventually have a firm that is responsible. And you certainly could think of doing a nonprofit firm, or you could just do a firm that absolutely cares about the community it works with. I think depending on the culture, in some cases, Germans are way more sensitive to that, and Europeans in general, in part because you pay double the cost of energy than the United States does. In the US, it's a different problem. There's about 70 million of us that don't really believe in climate change. That's a problem. So architects can use the power of our imagination and the tools at hand to show them how that impacts their lives, or produce a version of it in design that's stealth. We make projects where the sustainability aspect is hidden. It's kind of like Mary Poppins. There's medicine there, but it's surrounded by sugar. So you give them a spoonful of good medicine and they don't know they're getting it. So you work with your engineer colleagues and good developers, et cetera, so that you produce projects that are good for the environment, but you don't necessarily celebrate that up front. So you won't get the same amount of resistance. There's a lot of these strategies, and it's sort of sad that we have to do that. But the idea that we're in a society where we don't recognize any limits to capitalism, I mean, that goes back to the Club of Rome in the 70s. We have those metrics. And just like Greta Thunberg, who is more or less your generation, all she hears is blah, 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 blah. The leadership class standing up there and promising carbon neutrality, promising the end of oil by 2030, 2050, promising working on climate change. None of that's changed in my lifetime. So yeah, I think everyone needs to get more aggressive, or at least stick to their guns when it comes to the work they want to do. While you're young and still have a chance, you could do it now. Later on, you'll have kids and a mortgage, and then you'll be a sucker in the system. It'll be harder for you to change. So don't give up hope. Be radical and do things that you want to do now.
But actually, maybe this is one question back to you as students, because in my lifetime, I've never experienced the young population to be so empowered to actually stand up for their causes. I think Mitch just mentioned Fridays for Future, Greta Thunberg as the leader of this movement. And I think, yeah, right now, the problems that are addressed by the young generation, they are important and they are being heard. It probably has to be more, but I think you're also empowered in this way. And this also, of course, reflects in some of the politics, no? That we, for example, have just seen in Germany, I would say, with the Green Party getting a lot of votes from, the younger generation, so on and so forth. So maybe that's a question to you. Do you feel empowered?
In a way, yes, but if you look at activists going to Angela Merkel, there was an event where Luisa Neubauer, I believe, and Greta Thunberg met Merkel, and there was nothing achieved there. They were just coming out of the event, and they said that they didn't get to any resolution. So in a way, sure, but not that much, I would say. I don't know.
Yeah, but actually Mitch mentioned one very important word before, and that is perseverance. And, maybe also to conclude on some of the questions, but you can just never give up. I mean, if you have a cause, you might need to take 10 meetings with Angela Merkel to really convince her. Now she's not in power anymore. We all know that. But I think never giving up is, what's really important.
Maybe we can finish off with one last question that we got from the audience. It's a rather specific one, and it is a little bit of a change of tone, I suppose. So I'm reading the question from Simon. You have mentioned the big storage that is needed for cars, which are only used, for example, 2 hours a day. What do you think of the fact that of the two places much people living in a city have, first an office and second their flat, at every point of the day, one of them is not used?
Yeah, that's so that's a efficiency in use of space. Offices today, newer models like WeWork or shared or co-working spaces are becoming online more and more often in the major cities. Co-working spaces have proven to be very successful, both synergistically and combinatorially, because you get a lot of different people interfacing with different ideas and different models. So it's just healthier to have offices that are mixed, but it doesn't always work in all cases. And then for housing, housing is a universal problem that every culture, every race, every ethnicity, every nation on this planet is facing. And it's specifically an architectural problem in many ways, but not only, because it does have to do with policy, regulation, governments, and certainly ideas of economics. I studied housing for a solid year, both at Columbia as an architect, and then later on in urban design school. I studied at the Kennedy School of Government at Harvard to understand the policies in housing. And I could say that it is probably one of the most important problems facing architects today, and we need an enormous amount of energy to rethink it. There's some groups, there are many groups doing that. We haven't found the answer. I don't think it would be one answer. It will be a kind of a rainbow of solutions, But in general, if I had to say, if I'm going to argue between workplaces and housing, and this sounds very, very socialist, so there'll be some happy people there. Housing should be free forever for all people, and it should be the best possible, most amazing, especially architectural housing you could have. I don't think we should separate quality of housing from people's, from different income arrangements or different races or ethnicities. We're not there yet, but I think equity in housing is a major mission in architecture. And equity, not equality, but actual equity. So in the United States, especially in cities like New York, housing, goes, the poor clearly live in poor places. And that's just not acceptable anymore. We need to work further at that problem. So I don't know how we could solve it similar to the cars. We could think of kinetic spaces that collapse and are used for other things. There's a whole field called kinetic architecture, also deployable buildings and temporary buildings, and all of that's interesting and could engage in further research. But there's just a lot of efficiency that needs to happen in housing and in workspaces. Also, coming from apps and algorithms can help us optimize the use of those spaces, so we can get a lot smarter. Airbnb is a great example of a company that maximizes housing use, and Airbnb has been fairly successful. We need more things like that are more clever, that think at that scale between time and space and availability and connection between groups. It's possible to do it. It's moving very slowly, but that's I think answers that question.
Well, I want to maybe come up by thanking you on behalf of all of our students, on behalf of myself, on behalf of all of our viewerships from afar. I think it's been such a pleasure to hear you speak and to see your very interesting imagery. It's been very radical. It's been fun, I believe. And yeah, I look forward to reading more of your unfeasibility studies. And maybe Marcus, if you would like to add another note to that.
Thank you very much, to the two of you and everybody else involved in the discussion. I think it was an absolute joy to run through a couple of architectural provocations drawn up to a very beautiful, very explicit level, and also to invite us in. It really felt like a walk through a laboratory. To invite us into this kind of wide scope of thinking and of asking questions. And I hope also I would also like to thank the students for being extremely straightforward in their questioning. I'm looking forward to see this straightforwardness also happen in real space. Maybe the digital space allows us a little bit more radicality here. But I feel this format, with all its downsides today, was proving quite an amazing opportunity to come together and talk and create an energy between windows around fundamental questions. So like, what is our relation to society as architects, or what is our relation to the planet from a discipline? Are we a service crew? And if we are, to whom, and who writes our brief, and what is the service that we provide? Just to go back to these, are we servicing the humans? Are we servicing the butterflies? I thought your projects really gave us a lot of food to rethink the way we approach architecture. Thanks a lot.
Thanks, guys. Thank you very much. Hope to see you either in Berlin or come visit us in Brooklyn. Our doors are always open. It's a lot of fun over there.
Yes, thank you for the invitation, and also thank you again for the students for all the great questions, and also from the audience, of course.
Yes. Thanks, guys.
Bye.
Thank you.
Bye. Bye.
Have a good time, evening.